Okay, I'm going to run through differentiation and integration from Chapter 9 Core 2. This is where we start to introduce fractional and negative indices. So, if we start this off just by reminding ourselves of how to do differentiation, that'll probably be the best way. So, let's start with y is equal to 7x to the 4 plus 3x to the 8, take away 9x to the 9. Okay, so dy by dx shall be, now remember that the power comes down to the front, so we've got 7 4s at 28, and you take 1 off the power. The 8 comes down to the front, so we've got 3 8s at 24, x to the 7. The 9 comes down to the front, we're going to get 81 x to the 8. So we should all remember how to differentiate and be able to do a polynomial like that. Right, so now we're ready to see how it works with fractions. So let's say I've got y is equal to x to the half plus x to the, let's say, minus a quarter. Okay, and we can do dy by dx of this. Right, well, the same method applies. The half comes down to the front, and I take 1 off the power. So 1/2 take away 1 is minus a half. So now we've got x to the minus a quarter. The minus a quarter comes down to the front, and I take 1 off the power. So I get minus 5/4. So it works as simply as that. Okay. Obviously we can make this a little bit more tricky by first of all writing the question in this format. So square root of x plus 1 over x. In this type of situation you must write each of these x's as x to the power of something. So remember that square root of x is x to the half, and 1 over x is x to the minus 1. So now we're able to find dy by dx. So we get 1/2 x to the minus a half, and for this x to the minus 1, the minus 1 comes down to the front, and I take 1 off the power. Another format they could come in would be something like this. Let me just change it to pen. Let's think. They could have something like this: x squared take away, let's say x to the, let's say the square root of x is y equals, sorry, and on the bottom we'll have x. So you need to be happy to be able to split a fraction into 2 portions. Let's have that as x cubed, actually. Let's make it a little bit more interesting. Now, to the one side, I'm just going to write you a little example. Now, if I've got 3/4, you should be happy that that is 1/4 plus 2/4. Okay, so I'm going to use the same principle to split this fraction into x squared over x cubed take away, well, effectively x to the half over x cubed. Okay, so I've split the fraction. So now x to the squared divided by x cubed is x to the minus 1. And then we've got x to the half over x cubed. Okay, now 1/2 take away 3 is 2.5, is minus 2.5, so minus 5/2. Okay, so now we can work out dy by dx and differentiate. So the minus 1 comes down, I get minus x to the minus 2. Now we've got minus 5/2 comes down to the front, so that minus turns into a plus. 5/2 x, and I take 1 off the power, so I get minus 7/2. Okay? Okay, let's move on to integration. Now we're going to start off with something simple. So back to core 1 for a moment, and let's make sure that we remember the principle. So let's have, I don't know, plus 9x to the 3 take away 2x to the 7 dx. Okay, confronted with this problem, so integrate x to the 8, I add 1 to the power and divide by the new power. I add 1 to the power and divide by the new power. I add 1 to the power and divide by the new power. Notice how this last term can be simplified, so I can finish off by writing this as x to the 9 over 9 plus 9x to the 4 over 4 take away x to the 8 over 4. Okay, so that's a straightforward question. One thing that I've got and missed out, as always, okay, got to be very careful with it, adding a constant, because we're looking at an indefinite integral, okay, because there are no limits on the integrand. Okay, so now let's do this with fractions. So let's say I've got the integral of the square root of x plus 1 over x. Not 1 over x, let's have 1 over x squared. Now there's a reason why I'm not doing 1 over x, okay, because the integral of 1 over x gets you into logs, natural logs, okay, and that is beyond the scope of this topic. So let's deal with this. So first of all, we could rewrite this integral as x to the half, because that's the square root of x, plus x to the minus 2 dx. So I add 1 to the index, add 1 to the power, divide by the new power. I add 1 to the power and divide by the new power. Watch out when with negative indices here. Plus c. I won't forget it this time. So I can rewrite this. Now, dividing by 3/2 is the same as timesing by 2/3. So that's 2/3 x to the 3/2 dividing by minus 1. So we've got minus x to the minus 1 plus c. Okay? So it is relatively straightforward. We'll just go through one more challenging example. Okay, so this last example, let's write it as x to the x squared take away the square root of x. Let's actually have the third root of x. Let's make this tricky for me. Okay, x squared take away the third root of x over x to the 4 dx. Okay, so first of all, I can split this into x squared over x to the 4. Take away, now the third root of x is x to the third. Okay, over x to the 4 dx. Now, x squared over x to the 4 is x to the minus 2. X to the third over x to the 4. Well, 1/3 take away 4 is minus 3 2/3, which is minus 11/3. Okay, so minus x to the minus 11/3. I would have to go and give myself a challenging one, which we can now integrate. So I add 1 to the power, divide by the new power, and then I add 1 to the power, so I get minus 8/3, and divide by the new power, plus c. So simplifying this, I get minus x to the minus 1 plus 3/8 x to the minus 8/3 plus c. Now where does this plus 3/8 come from? It's because I'm dividing my minus 8/3 here. The two minuses cancel. That become a plus. They become a plus. Because I'm dividing by 8/3, it's the same as timesing by 3/8. Okay?